Good evening, sir.
Hi, Adrian. How you doing?
Doing good.
Good.
Guys,
Right, pause. How are you?
Okay.
I'm good.
All right, waiting for the others. You can look at those sets of items that I want you guys to research on. And we're going to start another round of presentation. So I'll give you a couple of minutes to do it. So if you want to select um, a pair of things to look at and start your presentation, I mean, preparations, I would appreciate waiting on the others to come. So you can look through and see which ones you prefer.
Sir, we're supposed to tell you now or just wait on the others?
Um, Early bird eat the most worm. You ever catch a most worm? You ever hear that terminology yet?
Yes, yes, sir.
All right. So because you guys are here early, you have an opportunity to go first. So whichever one that strikes your interest.
Okay, five and six.
Cause
Okay.
more fight you. And that me there too.
You should have talked early.
Joe.
Asia. I didn't see that of you at all.
Your look can be deceiving.
Trust me, I'm telling you. Oh, by the way, Mike is supposed to be um sharing some information with you. Somebody from work uh knows. I think it's a company that, well, he just responded to my text, so he's gonna be sending it. Um, there's a company that is in occupational health and safety that is looking for workers. So I told her that I have a set of students who are completing their course of study in another couple of weeks. Not sure if you guys are interested. I'm not sure if you guys are comfortable where you're at. You can nonetheless make some serious inquiries whether or not you are going to take it. At least you can make some inquiries to see if it is something that will suit your needs. I would say to you, if it is a contract work, no bother with it. It has to be a full-time, permanent job. Just play around with it. So he should send it off soon. You can look at it and let me know what you think before class ends tonight. All right?
Okay, sir.
Okay, sir. Sure, sure.
Mhm.
No, sir, I'll do 2 and 4 then.
Good evening, everyone.
Good evening.
Mikey, select either one or well, you have an option. It's on a first come, first serve basis. So you can do 1 and 3, or you can do 7 and 8, which you choose. I'm not
I
here.
like a challenge. I'll do 1 and 3.
Sorry, say it again.
I like a challenge. I'll do 1 and 3.
1 and 3, okay.
I want to Asia so much. That's the truth.
Although if you hear Asia answer past earlier on today, I would advise you to leave her alone.
So I can scroll up a little.
Sure, Papa. So you can start the preparations now, and then I'll give you some time, and then we can do brief presentations today. So how far we can get. Thanks.
Afternoon.
Asian curve.
How we see, guys? We're good?
Yes, sir. Still working on it.
Okay, man. No problem. Just wanted to know that you're still awake. Karen, how you doing?
Sir, still working, sir.
All right, no problem. All right, good job. I'm here. So I'm going to give you all another 40 minutes. At 6:30, you can start even a portion of what it is that you have. Maybe you're given 2 pieces each. You could do maybe one of those, so at least you can get some of the content in. All right. So in another 40 minutes, I'm going to come back to you. Thank you.
Okay, sir.
All right. So, as promised, now 6:30. Who wants to go first? You know that I can call upon somebody down.
Okay, sir. You hearing me?
Go and clear, please.
All right, I'll go first. All right. So I had question 1 and 3. Describe the structure and chemical composition of the atmosphere. So the atmosphere is a multi-layer gas envelope that surrounds the Earth, and we know that it has the gases that are primary for existence. It mostly has like nitrogen and oxygen and other trace gases and other compounds such as your water vapors, and you have stuff like your aerosols, your dust particles, your soot, your
What percentage
pollen.
of nitrogen and oxygen it has?
So it has 78.08% of nitrogen, and it has 20.95% oxygen. And then you have your argon, your carbon dioxide, your neon, your helium, your methane, your hydrogen, your ozone. Those are in trace form. However, your carbon dioxide and your methane, those fluctuate due to human activity. And as you know, those are two major greenhouse gases. So the atmosphere, it has five five layers. You have your troposphere, your stratosphere, your mesosphere, your thermosphere, and your exosphere, which is beyond your thermosphere. So that is 600 kilometers and beyond. Now, within your troposphere, you have that's your lower level. You have your clouds. That's where you find your storm. Your rain occurs in that area. It has a composition of nitrogen, oxygen, argon, and water vapor. And within that sphere, temperature tends to decrease with altitude by about 6.5 degrees Celsius per kilometer. And also, this is due to the reduced heat absorption by the Earth's surface. So the lithosphere actually absorbs all that most of the incoming radiation, and thus causing that cooling effect. And at the boundary, the uppermost part of the troposphere, you have the troposphere, and you tend to have these pores once you transition from one layer to the other. Now, your troposphere, it has your ozone. It's roughly 12 to 14 kilometers above ground, and your ozone really absorbs the harmful UV radiation that enters the Earth atmosphere. However, due to this factor, temperature tends to increase in your stratosphere, and this area is the most you find your ozone, your O3, and most commercial jets tend to fly in this area. You find your jet stream and all of those wonderful air masses um, within that area, within that sphere. Then you go to your mesosphere, which is the cooler part of the atmosphere, and this layer is roughly 50 to 85 kilometers above the surface, and this is this layer can go to temperature like 90 degrees, minus 90 degrees Celsius. The temperature decrease due to the lack of heat absorption. So your heat absorption really occurs in the stratosphere. So that's so you don't have that much heat being in that sphere. Now in this sphere you have like low density gas such as oxygen and nitrogen. And a quick gem is that in this is the sphere that you find that meteorites um, being burned due to the friction of the gases that are there. And you know that oxygen is a combustible gas, so that in itself helps.
Which sphere, sorry, which sphere is that? The mesosphere or the thermosphere?
The mesosphere.
Okay,
Yeah.
go ahead.
The thermosphere, no, that's the sphere that is very hot, reaching temperatures over up to 2,500 degrees Celsius. And it's simply because it's one of the most outer, one of the most outer spheres. And all that radiation from sun hits that sphere directly. It also contains the aurora light, the northern and southern lights, and it's mostly composed of oxygen, nitrogen, and lighter gases like helium. And if you know the gases that the sun has, it's helium and hydrogen, which tends to be, I think it's more, they tend to absorb heat more. So those are present. And in your exosphere, it's your outermost atmosphere over 600 kilometers. And this sphere is comprised of hydrogen and helium, the extremely low density gas, and the temperatures vary due to the solar activity. So in the daytime it's hot, in the night it's cold. And that's where you have your satellite orbiting. Now so the second question is effects of atmospheric particles, which are classified as aerosol, and also the radiation of the sun, from the sun on the environment. So your aerosols, they impact climate change and they regulate temperature. So the cooling effect of aerosol, especially like sulfate, from like the volcanic eruption, the burning of fossil fuel, they tend to reflect back like into the sun, sorry, into space, and that tends to reduce temperature. However, the carbon, like the soot, those black carbons, the soot from your biomass burning and the vehicle emission, those tend to absorb your solar radiation and those contribute to warming. So it increases temperature. And also these help in cloud formation as they provide the condensation nuclei, which we would have learned about in the hydrosphere, which changes, which helps in the formation pattern of clouds and help with the starting of precipitation. In terms of the air quality, if the particulate matter, the PM, are between 2.5 and 10, these can cause serious respiratory disease. So first with asthma, bronchitis, COPD, those persons would be impacted directly by these aerosols being within that particular matter size. And also, these aerosols, they come from industrial pollution, the chimneys from factories, the wildfires, dust storms. These tend to generate various sizes, and they also impact visibility. And you have the famous acid rain, which is formed from sulfur dioxide and nitrogen oxide. And these come from your industrial processes, and these vapors tend to form sulfuric acid, which is H2SO4, and nitric acid, which is HNO3, which leads to your acid rain, and your acid rain eventually damages your soil and impact your aquatic ecosystems and buildings, especially those that are made from your harsh material, the limestone. The impact of the solar radiation on the environment is firstly, it heats the Earth's surface, and this is the primary source of energy for the climatic system and all function on Earth. As you know, through the law of thermodynamics, energy is neither destroyed or created, is just transformed from one form to other. So your photosynthesis, where the plants use that solar radiation, that energy to make food, and then the different trophic levels, the food passes from, energy passes through the different trophic levels, and that's how we function. Now, the 30% of the incoming solar radiation, that is reflected by the clouds, the aerosols, and 70% is really, it's absorbed and it warm your climate, warm the planet. Now, the greenhouse effect is basically heat that is absorbed and re-emitted as infrared radiation. However, your greenhouse gases are your carbon dioxide, your CO2, your CH4, your HO2, and your NO2. And all of these tend to trap heat, keeping the planet warm. Now, the greenhouse effect is different from global warming. The greenhouse effect is simply just warming the Earth. Global warming is the increase in the ambient temperature over a period of time, and which basically has direct impact on several ecosystems and how we have life here. Now, the ultraviolet radiation is absorbed by the ozone layer, as was discussed in the stratosphere, and it helps to prevent us from that exposure, that radiation, that which will cause skin irritation, skin cancer. It can damage DNAs in plants and reduce the agricultural yield. And finally, the solar activity um, is actually influence, has a climate influence. So your solar cycle is roughly 11 years. It fluctuates, yeah, it's 11 years. And the period of the high solar activity is similar to a slightly, or let me repeat that. The period of the highest solar activity can slightly increase the global temperature, while the low activity will reduce it. So that's you can consider like a little ice age kind of thing where you'll have a period within your solar cycle when it's extremely cold based on the tilt of the Earth and how the Earth rotates around the sun. However, you have other periods where it gets extremely hot, and that is due to the Earth tilting and rotating more towards the sun. So, not a physics man, but let me see if I explain it very simple. So, as the Earth rotates around the sun, and it orbits around the sun, you have times within the solar cycle when it's much closer to the sun, and that's when it's at its peak. And you have another period of time when it's more further, and that's when it's at its lowest, and that's when it's colder. Um, Finally, um, the aerosol, it helps to scatter and absorb some of the radiation, and that heat influence the radiation balance on the Earth. And most geoengineering principles suggest that artificial aerosol in the stratosphere can help combating global warming, as it suggests that it does help with the balancing of solar radiation. So it's something that they're actually looking at. That ends my recipe. So, any questions?
Are there any questions for Michael? All right, so I have a few, and it's not for you to answer no, but to come back and give us some further explanation. The tropopause, the stratopause, the mesopause. You know, I need for you to tell me a little bit more about that layer. I also want to hear more about, yes, you've highlighted it, that the chemicals that exist in the atmosphere. You did speak of the nitrogen, and you spoke about the chemical composition of the atmosphere. You spoke about your nitrogen, you spoke about your oxygen, and that's why I asked about percentage, just to highlight the point that nitrogen is 78%, and oxygen is 21%. So the combination of those two already is 99%. True or false?
That's true.
Yeah, man. So you may have traces of carbon dioxide, maybe like at a 0.0 something. Huh? And then you may have some look
0.04.
0.4, right? Some books say 0.03. And you may have some oxygen, well, not oxygen, but argon and other noble gases in
Sir, quick question. Kr is krypton?
AR is krypton, yeah.
Okay.
And AR is argon. So you'll have some of those trace elements there as well. But we also spoke about okay, let me not preempt you there. You spoke about acid rain. What is a major constituent? And Asia, be prepared. You may start and have to stop, but be prepared because I'm coming in with you. What's the major constituents of acid rain, Michael? You spoke about it briefly just now.
Acid rain?
Go ahead. Yeah.
Well, they have two components, sulfuric acid and nitrogen, nitric oxide.
Nitrogen oxide.
Yeah, and sulfuric acid.
All right, so it's like it's a sulfurous acid that when
Sulfur.
combined, right? So when combined with the water, it produces a sulfuric acid. And you remember you spoke about the greater percentage of the nitrogen at 78 and 21% of oxygen. So you can have nitrogen oxide being formed. So the nitrogen oxide, NO2, you need to know how to do the bonding in those. Very important. So I want between you and Asia, no, it will be you, Michael, with the chemical composition. I want you to fine tune the presentation, and I want you to show me the bonding in the nitrogen oxide. And then you show me the reactions also when combined with water to form the nitrous no, not the sulfuric, no, man. The nitric acid, right? The HNO3, because we have NO2 for the nitrogen oxide, and the NO2 when reacts with water, the H2O is going to form the nitrous acid HNO3.
Yeah.
The HNO3, that's one. And also you spoke about the sulfur and the oxygen to form the, go ahead.
Sulfuric acid.
The sulfurous acid that when react with water is will form the H2SO4, the sulfuric acid.
Yeah.
Right. So those are two atmospheric pollutants. Right? They are atmospheric pollutants. Now, what I want you also to say to me, I don't know if maybe Asia will talk about it. Oh yeah, Asia will talk about it. So let me press pause on you because I'm going to come back. Because it's not just for you to present to get grades, but it's for you to present and understand. Very good, and understand what is happening. All right, Asia. In particular, I would want you to speak about number 2, the list of sources and types of atmospheric pollution.
Yeah, 1 second, sir.
So while you sort yourself out, this should strengthen your section, should strengthen Michael's section, and Michael should be able to ask you some questions to help strengthen your section because there's something. If you notice what I did, I put 3 up top and 2 down there, and there's a reason I did, but hopefully it will come out when you're ready.
So the sources and the types, you said?
Yes, ma'am.
All right, so some sources of atmospheric pollution, some of these may include volcanic eruptions, wildfires, dust storms, pollen and spores, and ocean sprays. So for volcanic eruptions, this may include the release of ash, sulfur dioxide, and others. For wildfires is the smoke and carbon monoxide release. Dust storms are sandstorms. They can give off particulate matter, which can affect individuals and animals, including plants. And for pollen and spores, we have biological pollutants. And ocean sprays, they release salt into the atmosphere, which prevents the composition of rain from clouds and others.
That's it.
Oh, this will be the natural. And for anthropogenic, we have industrial emissions, vehicle exhaust, waste disposal, agricultural activities, and construction and mining, where industrial emissions can release sulfur dioxide, nitrogen oxides, and particulate matter. For exhaust, from vehicles, we have carbon monoxide, hydrocarbons, and nitrous oxides again. Fossil fuel burning, or waste disposal, which can be from incineration, from burning of garbage, from landfills, which can release or produce methane and dioxins. And agricultural activities, which can be from fertilizers, where ammonia is released, and methane from livestock. And then our construction and mining, which can release separate particulates as well, the dust, the debris, and so on. And for the types, we have particulate pollution, gaseous pollution, photochemical, biological, radioactive, noise, and thermal. So for the particulate, it's the tiny or solid particles, solid liquid particles suspended in the air, like our dust, or soot, or smoke, not aerosols. They may come from like vehicle exhaust and construction sites, and these may cause respiratory problems and contribute to climate change. For our gaseous ones, there are harmful gases that change the natural composition of the atmosphere, which may include carbon monoxide, sulfur dioxide, or oxides, and these may lead to respiratory problems, again, acid rain, and environmental damage. The photochemical pollution. This is basically pollution caused by our sunlight reacting with other air pollutants like our nitrogen oxides. So, for example, smog, ground level ozone, and this also irritates lungs and eyes and reduces visibility in cities and so on. Biological, which are airborne microorganisms and organic materials, which are pollen, spores, bacteria, and viruses. They may come from natural plant processes and decay, and they can trigger allergies and asthma. For radioactive, we have the presence of radioactive substances in the atmosphere, like from our nuclear power plants, mining, and these can cause cancer and contaminate the environment as well. Noise, which is unwanted or excessive sound in the environment from traffic, construction, loudspeakers, and they may cause stress, hearing loss, and disturbances to sleep. And our thermal is the increase in temperature of the atmosphere due to human activities such as industrial processes, and this may alter weather patterns. And this is for the types. Should I continue with the impact, sir?
No, don't correct impacts yet.
Okay.
So thanks, Aisha. Don't move your screen just yet. Thank you. Michael, can you see now where yours kind of overlap with hers? Because the point I want to bring across is the different sources of the sulfur dioxide to the atmosphere. You have those from industrial waste. You have those that are also produced by us driving our vehicles. So you will have a good source of carbon monoxide that is produced. You'll also have the nitrogen oxide that will also be produced in that process. I'm going to come back to this next week, God's willing, because this is the interesting part of it now. Now, one of the things I wanted to discuss with you is, so we need to look at mitigation. Now, as environmentalists, identifying the sources is one thing, but how then are you going to be able to mitigate? That's the point I was trying to make, Michael, when we had a conversation last class about the production of the 330 milliliters water from Lasco, for argument's sake, and the 500 and the 600 and the 591, so forth and so on. And you were saying that persons are not, persons love the convenience. It's not a matter of convenience. Once you're an environmentalist, it's not a matter of convenience. It's a matter of what does best for the environment. Now, going back to what it is that we're talking about, even if they were to use the same material to make a 5-gallon water bottle that they would for the 330, at least you'll have less of those 330 bottles roaming in the environment that incidentally are not biodegradable. So here it goes. We have one bigger container that could maybe, for every 100 or 200 little bottles, we have this one big bottle. It means right there and then that we would have saved the environment of 100 plus more smaller bottles that gets into our rivers and streams. that gets to clog the drains and cause flooding, which is another form of pollution. It's another form of pollution. The photochemical pollution is very important, and I want you to be able to itemize the reactions that take place within the photochemical pollution. Noise pollution, yes, is one, but I don't think they will ask you as an environmentalist really about the noise pollution. It's more the chemical one that they will talk about. So the photochemical is very important. If you look at it, you recognize that there are many sources of sulfur dioxide and nitrogen oxide. You spoke about several, Asia, and Mikey spoke about some. So we need to be able to tie those together to see how best we can reduce the input of these harmful gases in the atmosphere. Let me ask you a question. What mitigating strategies? I'm not sure if you got there yet, Asia or Michael, Paz, Karel, all of you. How can I mitigate the impact of sulfur dioxide and nitrogen oxide in the atmosphere coming from vehicles?
Sir, well, the number one where people always say like educate the people them on the harmful effects of it or how to reduce it.
Yeah, put it this way. All five of us are in a family.
Mm-hmm.
And all of us have our own cars. All of us work.
Carpool. Sorry.
Okay, good. So all of us work in the New Kingston Excelsior area.
Mm-hmm.
So mommy and daddy work in New Kingston. One of the children may work at Excelsior, the other one may work down Morosco Road, and the other child works up in Ligoni. So we all work within the same region. We all leave the house around about the same time. And we get home maybe a half an hour or an hour from each other. So yes, carpooling is one way. Now, I will tell you as we wrap up for this and for this weekend, what I'm going to ask you to do. Thank you, Michael. Thank you, Asia. Asia, I know you did yours in parts, but Michael, Asia, I'm going to ask you to go back and fine tune what it is that we're looking at, because I'm going to be introducing to you one of the things that we call a catalytic converter. Now, a catalytic converter is a device that is attached to the muffler system of motor vehicles rather. And it is by law in some countries. And if it is that you don't have a catalytic converter attached to your vehicle, there is no way you can get insurance. So it must be attached. And what it does, it converts those dangerous monoxides into useful carbon dioxide. And you may say, but sir, carbon dioxide is not good for the atmosphere. Yeah, we know. But remember, if it is that we plant more, it means that the green plants, in the presence of chlorophyll, which is a green pigment, will use that excess carbon dioxide from the atmosphere for to produce our C6H12O6, which is our glucose, during the whole process of photosynthesis, right? And of course, we'll have some of the aqueous carbon dioxide getting into our hydrosphere. And it's going to be very important for the carbon dioxide, the aqueous carbon dioxide, to get into the hydrosphere. Because you talk about now shells and clams, how you think barnacles and shells and clams are formed, are produced. One of my pastimes is to go with a family member on the beach and just pick up shells. I will look for unusual shells and carry them home. We carry them home and just keep them. How are those formed? They are carbonates, right? So, and which is why the carbon cycle, as I told you, is very important for us to look at, right? So, in some countries, you can read upon it, in some countries, there is a black market for catalytic converters. So you have your converter attached to your vehicle, park out a door, And by the time you come, there is no converter there because it is now removed and sold on the black market because somebody needs to go and get their car insured, whatever the situation is, so forth and so on, right? So we have to be able to speak about the sources of the air pollution or the atmospheric pollution. It is very important. You can get a question on atmospheric pollution. All right. And of course, we have the other sources, Riverton, motor cars, motor vehicles. As Asia put it there, photochemical is one. Volcanic ash is another one, especially if you have the Pelion type volcano, the one that shoots all the way up into the atmosphere, and then it just branches off like an umbrella and just form a coating. The Sahara dust is another example of that, propelled by wind. So it gets interesting. To be continued, I'm going to ask that you to fine tune it for me for next class so we can have a fulsome conversation on the matter. Fair enough?
Yes, sir.
Yes, sir.
Congratulations. Any questions before we wrap?
Sir.
Who do you have now? Go ahead, Karen.
No, sir, I was just saying no. No question.
Okay, who do you have now?
So we Dr. Godapati.
Dr. Gurapati. Have a good one. Big up yourselves.
All right.
Cool.